Have you ever wondered why the Philippines seems to be constantly in the news for powerful typhoons? I mean, it's a country that faces some of the most extreme weather anywhere on Earth. Well, today, we're going to dig into exactly why this archipelago is such a global hotspot for these massive storms. Let's break down the science behind this perfect storm. So, to really get a sense of the scale here, let's start with this number, 20. That is the average number of tropical cyclones that enter the Philippine area of responsibility every single year. And about half of those will actually make landfall. That's an almost constant threat that shapes life for millions. So, that leads us to the big question, right? Why? What is it about the Philippines that makes it so uniquely vulnerable? Well, I can tell you it's not just a case of bad luck. The answer is this fascinating mix of science, geography, and a few other things. The truth is, it's not just one thing you can point to. It's really a combination of several powerful factors all coming together at the same time. Think of it like a recipe for a perfect storm. And we're going to go through each ingredient one by one to see how they create such incredibly powerful weather. Okay, so ingredient number one, and honestly, this is the most critical one. It's all about location, location, location. Simply where the Philippines is on the map puts it directly in the line of fire. You see, the country sits right in the middle of what's known as the Pacific Typhoon Belt, and that phrase on the screen says it all, an ideal breeding ground. That's exactly what it is. It's like a giant incubator for storms, all powered by some of the warmest ocean waters on the planet. And that warmth, that is the absolute key. A typhoon needs ocean water that is at least 26.5 degrees Celsius to get going and to build up its strength. This warm water is like high-octane fuel. It evaporates, rises into the atmosphere, and then releases an enormous amount of energy. That's what gives these storms their immense power. And the waters around the Philippines? They consistently meet and even exceed this temperature. But wait, there's actually more to the location story. The Philippines is also situated in something called the Intertropical Convergence Zone, or ITCZ. Basically, this is a belt near the equator where winds from the northern and southern hemispheres crash into each other. That collision creates the perfect, unstable, low-pressure conditions for storms to bubble up. You add that to the fact that the Philippine Sea is one of the most active storm basins in the world, and you have over 7,600 islands acting like a giant storm catchment zone. It's almost impossible for a westward-moving storm to miss. All right, let's move on to our next ingredient because it's not just about the ocean. It's also about what's happening in the air. The seasonal winds, what we call monsoons, play a huge role in both steering these storms and keeping them going. So, the Philippines has two major monsoon seasons. You've got the Habagat, or the southwest monsoon, from around June to November. This one pulls in all this incredibly moist, warm air from the ocean, which is exactly what a typhoon needs to stay powerful. Then, in the cooler months, you get the Amihan, or northeast monsoon, which can actually act like a steering current, guiding storms that form way out in the Pacific right towards the islands. The big takeaway here is that between these two wind patterns, the country's facing a nearly constant year-round threat. So we've got location and we've got climate, but there's a third factor in our recipe, a much more modern one that's acting like a massive amplifier on this already dangerous situation. And you've probably guessed it, that's climate change. Now, this is a really, really important distinction to make. Climate change isn't necessarily creating more typhoons. The frequency, the number of storms per year isn't really going up, but the intensity, that is a whole different story. The storms that do form are becoming so much stronger and way more destructive. And the science behind this is pretty straightforward. As our oceans get warmer, more water evaporates into the atmosphere. More moisture in the air is basically more fuel for the storm's engine. That leads to more intense rainfall and much higher wind speeds. This is why we're seeing a scary rise in what we call super typhoons. These are the absolute monsters. Storms like Typhoon Haiyan, which was known locally as Yolanda, that brought just unbelievable devastation back in 2013. So we have these supercharged storms forming in the perfect spot, steered by seasonal winds. But the story doesn't end when the typhoon finally makes landfall. In fact, the country's own landscape, its geography, can actually magnify a storm's destructive power. It's all because of a process called orographic lift. So imagine a typhoon's winds just packed with moisture slamming into one of the Philippines' many mountain ranges. That air has nowhere to go but up. As it gets forced rapidly upwards, it cools down, and all that moisture condenses and gets squeezed out like a sponge, creating truly torrential, unbelievable amounts of rain. This is what triggers those devastating flash floods and landslides we so often see. And this is where the human element makes it all so much worse. A huge portion of the country's population lives in these low-lying coastal areas. They are literally on the front lines, directly exposed to storm surges, massive flooding, and the full force of the wind. It makes the human cost of these storms just tragically high. So, when you put all of these different pieces of the puzzle together, you really start to see why the Philippines is in such a uniquely tough spot when it comes to facing nature's raw power. It really is the perfect storm recipe. You've got the prime location in the Typhoon belt, fueled by that super warm ocean water. Then it gets steered by powerful monsoon systems, amplified by our changing climate. And then the damage is made even worse by the country's own mountainous terrain. Any one of these ingredients on its own is a huge challenge, but when you mix them all together, you get the constant and severe threat the Philippines faces year in and year out. So that's the science. Understanding why this all happens is the critical first step. But it leaves us with an even bigger and more urgent question for the future. As these storms inevitably continue to grow stronger, how can we all better adapt and prepare for a force of nature that is constantly evolving?